Good morning. So the first session of the day, welcome. My name is Joachim Nordström, and I'm going to give a deep dive into the JDK Flight Recorder and present some of the APIs that are available in the JDK. And I work in the Java product group at Oracle. I'm a sustaining engineer, which basically means that I help our customers keep the old LTS releases up to date. And I kind of know, I think you know what the flight recorder is. But just as a small summary, it records events from the JVM, the JDK, and also the application. And it's highly integrated into the JVM. And it gives us a unified way to inspect the entire software stack from our application layer down to the JDK and all the way down to what the JVM is doing. And since it's so highly integrated into the hotspot JVM, it has a really low overhead, and it's basically designed to be always on. And this is the agenda for my talk. We're going to look at how we can start and stop recordings and how we can analyze these recordings. And then we're going to create and use some own custom events. And then we're also going to look at some APIs to consume these events programmatically. And then we're going to look at how we can use the JFR in unit tests. And we're going to start with starting some recordings. And the JVM comes with two configurations for JFR. We have the default configuration, and they are in the libjfr directory. And the default configuration is, it's designed to be always on. And at most, it has like less than 1% overhead. So there should be no, you shouldn't be afraid of using the flight recorder. There is also a profiling configuration, and that can have some more overhead, but it's usually just, well, not usually. In the worst case, it's like less than 2% overhead. And the difference between the default and the profiling configuration is that we have slightly changed the threshold, so you will get more events and a few more stack traces to some of the events. And a pro tip is to not actually alter these files. They are regular XML files, so you can indeed change them. But if you want to create your own custom configuration, please make a copy of these files and name it to something suitable. Because we've had cases where customers have changed the default configuration and were surprised to see that they either got lots of events or no events. And you can use the JFR command line tool to create these configurations. And the way to start the flight recorder is just to add a start flight recording parameter to your Java command line. And with this, you will get a continuous recording that kind of follows, that is always on during the lifetime of the JVM. And by default, if you don't set any options to the start flight recording parameter, you will get the default max size is 250 megabytes. You can also set a max age option, and this will give you, then you know that you always get the last 10 minutes of what the JVM was doing. And if you set the max age, I suggest you also set the max size to something that your disk can hold. Otherwise, if you have lots of custom events or something weird happen, it can fill your disk if you, during these 10 minutes, have lots and lots of events. So the max size is just to make sure that the JFR files don't fill up your disk. We also have another option, and you can combine these options, of course. This dump on exit makes sure that when the JVM exits normally, you will get a recording dumped to disk. If your JVM crashes, however, there will be an emergency dump that JFR will create if it crashes. And you can also add a file name and tell it where to put this recording. So now we know how to start Flight Recorder from the Java command line. So we have a recording that is always on. But if you, for instance, want to start a profiling session, we can start recordings during runtime, and we can use the jcmd command for this, and use the jfrs.start command. And here I target a certain JVM with a process ID, and I tell it to use the profile settings. And if I add a file name, I know where the file will end up. And I can also add a duration, which means that we start a recording that will record for 10 minutes and then dump the file to profiling.jfr. And when this recording is done, the profile settings will not be used, but it will rather use the default configuration that is in the continuous recording. We also have a few other jcmd commands to control our recordings. jfr.start I mentioned. jfr.dump can be used to dump an ongoing recording. So if you want to dump like the continuous recording, you can use the jfr dump to write it to file. You can also stop recordings, and you can see which recordings you currently have with the jfr.check command. So now that we know how to start and stop recordings, I'm going to look at how we can analyze these recordings. We have the JDK Mission Control, or JMC for short, and this is a graphical interface to analyze recordings. JMC can actually do, it can actually control a JVM as well, but I'm just going to focus on the recording analysis here. And this is a separate download. And you should always use the latest version of JMC, regardless of which JDK version you're using, because the recording format hasn't changed that much. Included in the JDK is also the JFR command line tool, which is, it can do some JFR-related things. You can list events and output them as text or JSON for recording. It can also help you create these configuration files. And it can be used to disassemble chunks from a recording. If you have, for instance, a very large recording, then you can disassemble it into smaller chunks. And you can also do the opposite. That is, if you have a lot of JFR chunks, you can create a new recording out of that. Because internally, while JFR is running, it creates lots of small chunks, which are like 12 megabytes, and these are like standalone recordings, and they are stored in a temporary directory, like a repository. And if you have like a really bad JVM crash, you never do that, but if you had, then at times, if it's a really bad crash, then JFR might not be able to create this emergency dump that I talked about. But then there could be like some leftover chunks in this repository, so we can still perhaps get some information on why the JVM crashed. And if you have these JFR chunks, then you can use the JFR tool to assemble them into a bigger recording. And there is also a command to scrub events from a recording, and that can be used to remove like sensitive data from a recording if you want to share the recording with some third party or something. We also have a new concept in JDK 21, so-called views. And these are views that like show aggregated event data, and you can use it to get like a view on either ongoing live recordings. So you can use JCMD to connect to a running JVM, or you can use it on already done recordings. And for JCMD, you use the jfr.view command and then say which view you want to see. And JDK 21 comes with 70 predefined views. And if you do the JFR help view, you can get a list of all of the views that we have. And if you want to know more about these views, you can read my colleague's log entry there on this feature. So that's a bit about how we can analyze recordings. But now we're going to jump in and create some own custom events. And to like set the scene here, I've created a small business application. I call it the Java dumpster because it's basically a big dumpster of different codes. And this tries to mimic like a real world application. But in short, it's a server application. It's currently built on Jetty, but I will be adding Micronaut and Tomcat and WebLogic and whatnot for other services. It's built on JDK 21. And in short, it expects that there's a client somewhere that makes requests to this business application. And the business application has some business logic that takes the destination from the request and then decides which service should fulfill this destination. So that's our example. This is basically where we will use our event. So we have some sort of a lookup service method that, depending on destination, chooses different services. And the requirements for this application is that we want to monitor all the service calls, and we also want to catch unhandled destinations. And in order to do that, we want to create our own JFR event. And we start by creating an ordinary Java object. We call it service call event, and we add a destination so that we can track which destination. And then we also added the service class so we can see which destination used which service class. And if we extend this simple Java class with the jdk.jfr event, we actually have our own custom JFR event. And this is basically all that is needed to create your own JFR events. But you should always add this name annotation. If we didn't add the name annotation, the event would get the name package plus the class name. But it's always a good idea to add this name annotation because we can. It makes it easier to refactor or move stuff. And you can see that I also remove the monitoring an event from the package name, so I made it a bit smaller. You can see that in my class, I have the postfix event, which I removed from the name because the name is what we'll see in the JFR context. And in the JFR context, we know that this is an event because that's all we have in JFR. However, in the Java code, it might be good to add the event so we know that this is an event and not the actual service call. And yeah, the name should be unique. And yeah, use the reverse domain name notation, just like the package names usually do. We can also, or should also, add a label. And this is supposed to be human readable, and it's supposed to be capitalized because this will appear in like headers and so. And we can also add these to our fields. So you see I added a label for the destination, but I didn't set an explicit name here because I think the name destination is fine, so it will use the name destination. But in the service class, I set the name to service class and remove the impl word in the middle of the field. And then I also added the label. We can also add a category, and this will create a hierarchy for our event. So this event will appear under the services category, and the services category will appear under the business application category. And now we have our own event. So with that event, we want to add it to our business logic. So we go back to our lookup service method. And we start by creating our service call event. We set the destination to whatever destination we got from the call. And then we call this begin method. And this begin method comes from the JDK JFR event. And this will set the start time for our event. And then we do our business application code where we check the destination. And once we decided which class to use, we set the service class to our service call event. And then we commit this event. And it's not until we commit this event that it will be actually committed to the JFR recording. And yeah, that's about it. So now we can track all our service calls. But we also wanted to add a handler or an event if we got like unhandled destinations. So we had a default case, and I have a case unknown here. And here we can add our unhandled service call event, set the destination, and commit that event. And because I return null here, our service call event won't be committed. So for each service call, we will get either a service call or an unhandled service call. And now that we have implemented our own custom events, I want to step back and just show you how this will look in JMC. So we take a recording from our business application, we go to the event browser, and here we can see all of the event types that we have in this application. And the 5 bottom ones, the Flight Recorder Java application, JDK, JVM, and operating system categories are the events that the JDK comes bundled with. And on the top, we have our own business application category. And if we expand on that, we can see that we have some sort of data category and our newly created services category. And under the service category, we have our service call and our unhandled service call. And just to be super clear on what we see here. So the label is what we see in the interface, and we have the category that creates the hierarchy. And then to drill down on this service call, we can mark it, and then we'll get all of the details that we have in our event. So the first 4 columns, start time, duration, end time, and event thread are like default fields that appear in the JFR event. And then we have the service implementation class and the service destination, which were our own custom fields. Yeah, and now I'm going to show a bit how we can consume events programmatically. I'm going to go over these classes. We have the event stream that can stream events from a recording, and we have the recording class that we can use to start and stop recordings programmatically. I'm also going to look at the recording stream and the remote recording stream. And for this, I have an example use case. We have our JVM that apparently takes up a lot of CPU, and we don't know why. And in order to understand that, we want to create some sort of thing that when the CPU load goes high, we want to dump a JFR recording. So we start by creating our method, start CPU load monitor, that takes a path to where we should dump the JFR recording. And then we have some sort of check where we check if CPU load is above 0.8, we dump the JFR recording to the destination. And we start by creating a new recording stream. To that stream, we add an event handler for the jdk.cpu load event, and we get the CPU load field from that and check it. We also enable the CPU load event, and I set a period here so that I will get this event once every second. Now, if I only do this, we will get a recording if the CPU load goes above 0.8, but we will only get the CPU load event, because when we start a recording stream without an argument, it will like create an empty stream, and we have to explicitly enable the events we want. But for this case, I will then just pick up our default configuration and add that to the recording stream. So now we have a recording stream with the default configuration. And since I want my CPU load event to appear every second, I add this enable and with period. Yeah, and then we have to start our stream. And that's basically it. So now when the CPU load goes above 0.8, we will get a JFR recording. And with this recording, I just want to briefly show how we can analyze it. We can start by using the JFR view. Here I choose the view thread CPU load, which gives a list of all the most CPU consuming threads. And we can see that we have a lot of like credit crunch threads that appear to take up our CPU. And in order to understand what this does, we can open the recording in JMC instead. And we can see here already on the automated analysis results that we have a high JVM CPU load. But in order to really understand what the problem is, we go to the event browser, go to our thread CPU level. We can sort on the CPU consumption and see our credit crunch threads here as well. If we right-click here, we can store and set this as a focused selection. And if we check the show concurrent checkbox, we will get all the concurrent events that happened at the same time as this event. So we go to our thread dump, and here we can see all our credit crunch threads, and we can zoom in on that and see which service caused this CPU consumption. So we install this CPU load monitor to all our servers, and we think we're happy. However, we have this cluster of JVMs, and when the CPU load is too much, these JVMs get killed because that's how it works. But when the JVM gets killed, we also lose our recordings. And we can solve this by, instead of storing the recordings on each server, we can create our own like central server that should store all our recordings. And this can be done by slightly altering our CPU load monitor. So we're going to do a small refactor here. Instead, we add the host to each server. And then instead of using the recording stream, we use the remote recording stream. And in order to know, so this code will live on this middle server that has that should store all our recordings. So in order to know which server it wants to take the recordings from, we have to add like a JMX connection. I'm not going to go into the details here, but it's basically just taken from the documentation. But we add this MBean server connection to the remote recording stream. And this will then create a recording stream that goes to that server that we have pointed out. And since we're moving all of the recordings to the client, we have to set like a max age or max size option on the actual client so that we don't fill the client's disk. Yeah, and that's about it. So now this code will we will add to our client side, and the client side invocation is really simple. We just start the remote monitor and tell it which server to take the recordings from, and then on each server we have to add like the JMX connection properties. But that is also, yeah, it's just in the documentation. So, lastly, I want to show how we can use events in unit tests. And for that, I have this example where we want to find out if any of our services uses the deprecated finalizer. With this JEP to deprecate finalizations, we also added a new JFR event, JDK.finalizersstatistics, and this gets emitted every time we have we instantiate a class that has a non-empty finalize method. So this is what we want to catch. So we should add a test case that capture all of these events. So we start by creating this unit test. We have our assert on the bottom there, where we make sure that this list of finalizers is empty. We have some sort of method that can call all our services to catch all the classes that might have finalizers. And then we start a new recording stream. We add an event handler for this event, and if we get the finalizer statistics event, we add it to our classes with finalizers list. We also enable this event, because now we will only get this event since we don't supply any configuration to the recording stream. And then we start async, which will start a thread with the stream. And then we call all our services, and then we just call the stream.stop. And the stop method will stop the stream and also flush out any events that have been committed. And hopefully all our tests will pass. And this stop method is new in JDK 20. So before JDK 20, I'm just going to show this very briefly. We have to do it in another way. We move our event handler a bit later. Instead of a recording stream, we start a recording. We enable the event in the recording. We start the recording, call our services, stop the recording, and then we dump the recording to a temporary file, and we can use this temporary file. We open this temporary recording with event stream, and then basically do the same thing. So this is if you're JDK, any JDK below JDK 20. And then we also have to delete the temporary file. I also just wanted to mention that there is a third-party JFR unit framework. It's created by Gunnar Moling, and it's on his GitHub. And I just wanted to show you, I haven't worked much with this, but I thought it was kind of nice, because you see the same test that I just did using JFR unit looks like this. So we can enable the event with an annotation and only just have our call all services call. And then we wait for all the events to be emitted and just make sure that we didn't get the finalizer statistics event. And lastly, I also wanted to show how to enable and disable events, which can be good to have. Here we have like a for loop that reads a lot of bytes from some sort of backend, and this backend is like flaky, and so we want to add an event to see why this backend call takes so much time. And so this is a loop that just reads lots and lots of bytes in some sort of way. So we create a custom event bytesRead that just records how many bytes we have read. Oh yeah, I added an annotation there, data amount. That's just the metadata to allow the user interface to understand that these bytes is a data amount and can format it appropriately. We have some other annotations to help visualize the data. But we add this event, we begin the event, and after we have done our backend read, we call the end method, which will stop the timer. Then we add the number of bytes read, and we commit this event. And now, if this is, as you can imagine, we're doing some sort of backend reading lots of bytes. So in the normal scenario, this would generate a lot of events. And we want to catch these events, but maybe not in production. So we can add this annotation enabled. And if we create custom events, they are all enabled by default. But if we set this to false, then this event won't be enabled by default. And that will, then this event won't be enabled and it won't be committed if we are in production, for instance. And with it disabled, then the JIT compiler can actually see that this event isn't used and can skip creating that event altogether. Just briefly wanted to show this as well. Just as an example, the backend can apparently give us more details on what it did. And this is a costly call for some reason. We don't know. But then we can also use this is enabled to actually just do this get details if the event is enabled. Because depending on what the get details method does, the JIT compiler might not be able to catch that this code isn't actually used. So if you have more complex things to add to your event, you can use the is enabled method. And there is also this should commit call that returns true if the event is enabled and it is supposed to be committed once we call commit. And these events can be set to have a threshold. I added the annotation here, so it's 50 milliseconds, which means that if the duration between begin and end is more than 50 milliseconds, then the event will be committed. But if it's less than 50 milliseconds, then the event won't be committed, and then the should commit will return false. Since we had this event by default disabled, if we want to add it to a test, we have to enable it. If we want to enable it in runtime, in production or wherever, we can use the jcmd command to start a JFR recording. And if we add this plus and the name of the event, we can enable that specific event. And just briefly to show how we can use the JFR command line tool to create our own configuration. We can build a new configuration using the input profile configuration and then enable this our own event and create a new configuration for this. yeah, so the agenda is over. I think I covered what I wanted to cover. Any questions? Yes. Yes, yes, it's available in OpenJDK, so it's part of OpenJDK. So yeah, I think it's integrated into Hotspot VM, and so if you're using the Hotspot VM, which you usually are if you're on OpenJDK, it's there. I think IBM J9 might not have it in some versions, but yes. No, you don't have to create your own custom events. Because the JDK comes with like 160 events that monitors what the JDK and JVM does. So you can absolutely enable JFR and get all events. Yes. Yes, you can start with the default profile and get data. Yes. Yes, there is some support for virtual threads. I haven't looked that much into it, but yes, there is support for that. Any more questions? No? Great. Thanks.